Hello everyone, welcome to the next lecture on the quadrature formula. Today I will explain you the concept of the 1-point Gauss quadrature formula and 15 plus numerical examples. Myself Dr. Harish Garg, you can follow and subscribe my YouTube channel Dr. Harish Garg. Now what we have discussed so far, we have learned the concept of the Gauss quadrature formula, and I will in that lecture we have learned how you can approximate. Remember that the Gauss quadrature formula will always give you the approximate answer of the integration -1 to +1 fx. Here the value of the lambda is known as a weight and xi is known as the positions or called as the nodes. Both are unknown to us, and our target in the Gauss quadrature formula is to calculate the value of lambda I and xi. Based on the value of the n, we can define the Gauss quadrature formula as a 1 point, 2 point and 3 point. In the 1 point Gauss quadrature formula, the value of the n is taken as a 1. In the 2 point, we can take an n is 2, while for the 3 point, we have taken n is equal to 3. The 2-point Gauss quadrature formula in detail we already explained. You can watch the playlist Numerical Linear Algebra and you can see the derivation of the 2-point Gauss quadrature and the 15 plus numerical examples of the 2-point Gauss quadrature formula. In this lecture, I will explain you the point of the concept of the 1-point Gauss quadrature rule. After this lecture, I will explain you the 3-point Gauss quadrature rule. Now, what is the derivation of the 1-point Gauss quadrature rule? In the Gauss quadrature formula, if I simply take n is equal to 1, then what will happen? This integration, that is -1 to +1 f of x dx, it becomes, when n is equal to 1, that number will be lambda 1 f of x1. Is it fine? Then your target, what is your target? Your target is to find the value of lambda 1 and x1. And you can see how many unknown parameters. Now since there are two unknown terms, fine. So we need a polynomial fx with the two arbitrary constants. So I can say a0 plus a1 x, two arbitrary constant. If there are the three arbitrary constant, then you can write as a 3 arbitrary constant polynomial. Always remember fx is a polynomial. But in this case, there are only 2 arbitrary constants. So I can write fx is a0 plus a1x. Or you can write only as the basis of the fx. What is the basis of the fx? What is the coefficient of the a0? 1. What is the coefficient of the a1? X. So I can simply say the equation number 1 is exact. We can form the exact by using fx is 1 and x. What is the meaning of that? If you substitute f of x is equal to 1 in the equation number 1, what will happen? The left hand side becomes -1 to +1, 1 into dx. It is equal to lambda 1. What is the value of the f of x1 is 1. On the other hand, if I substitute f of x is equal to x on the left hand side, this number is x into dx, which is equal to lambda 1 into x1. Now can you solve this integration? The left hand side is my 2, which is equal to lambda 1. If you solve this integration, the left hand side is a 0. Why? Because integration of the x is x square by 2 from -1 to +1. That number will be half minus half, which is 0. And the right hand side is lambda is my 2 into x1, which implies x1 is my 0. Fine. Now my target is to find the value of the lambda 1 and x1. So therefore, the 1-point Gauss quadrature formula becomes -1 to 1 fx dx is twice f of 0 is the required derivation of the 1-point Gauss quadrature formula. But make sure students, whenever we are talking about the quadrature formula, either as a 1 point, 2 point or 3 point, your domain must be from -1 to +1. It is not from any arbitrary a comma b, but it must be from -1 to +1. But what will happen if my domain is integration of 1 to 3? or integration of 0 to half, or integration of minus 0.1 to 0.5, and so on. How you can apply the Gauss-Legendre quadrature formula or the 1-point Gauss quadrature formula? Then your target is to convert the domain a comma b to -1 comma 1, and we all know how you can convert them. We can use some substitution, and that substitution is defined as x is equal to b minus a divided by 2 of u plus b plus a over 2, where a and b are the lower limit and upper limit of the integrations. I will explain you this concept with the help of the 15 plus numerical examples in this video. But before I start with the first numerical example, kindly like and comment on this video as well. If you are new to my YouTube videos and you still not subscribe my YouTube channel, you can click on the subscribe button and follow my YouTube channel. Now look at the first example. Now you have to apply the 1-point Gauss quadrature formula. Remember, the integrations limits must be -1 to +1, and it is already there. Fine. And once the function limit is already there, then we can apply the Gauss quadrature formula directly as twice of f of 0. What is the fx? Your f is the portion which is riding inside the limits. So fx will be e raised to power minus x over 2. So you can substitute them twice of e raised to power minus 0. E raised to power minus 0 is my 1. So answer is 2 is the right answer. Fine. Always remember, this is always my approximate because we are using the quadrature formula. Fine. Now look at the second example. Second example is, you can see the domain. Domain is my 0 to 2. That means lower limit is my 0, upper limit is my 2. So your first target is to convert this limit is from -1 to +1. How you can convert? I can use the substitution b minus a over 2 into u plus b plus a over 2. I can substitute the lower limit and upper limit. Can you get the value of the x? B minus a over 2, b plus a over 2. Fine. So x will be my u plus 1, and we also need the dx. Therefore, dx will be du. You can find the dx is du. Now you can substitute the values in the given function. So it is integrations from -1 to +1. X into x. What is the value of the x? U plus 1 e raised to power u plus 1. Dx will be du. Fine. Now the limits are from -1 to +1. Therefore, by using the 1-point Gauss quadrature rule, I can start with the twice of f of 0. What is the f? In this case, f will be my this number. Always remember, in the Gauss quadrature formula, f is the part जो -1 से 1 की लिमिट में होगा. That is my f. So if I substitute 0, it's a 0 plus 1 e raised to power 0 plus 1. So the answer is 2 into e is the right answer. Okay, compute the integral by using the Gauss quadrature 1-point formula. Again, you can see a is my 0, b is my 1. So your first target is to convert the limits from a comma b to -1 comma 1. I can use the substitution. X is equal to b minus a divided by 2. That number is half of u plus half. Therefore, what is the dx? Dx will be half of du. I can substitute both the values in the given integral. You will get I. Limit is from -1 to +1. 4 plus twice cos of x. X will be u plus 1 over 2 into half of du. Now I can take an half is my outside. -1 to +1. 4 plus twice cos of u plus 1 over 2 into du. Fine. Now, since the limits are from -1 to +1, now I can apply the 1-point Gauss quadrature rule. Half is outside, so that number is half. and function is 2 into f naught. What is the f? The function which is written inside the limit, that number is my f. So I can substitute 2 and 2 will be cancelled. So that will be 4 plus 2 cos 0 plus 1 over 2. That will be 4 plus twice cos of 0.5. Now you can use the calculator and you can solve them, you will get the answer. But make sure students, once you can use the calculator, you have to set your answer of the cosine in the radian. Make sure you have to set your answer in the radian, not in the degree. Fine? Not in the degree, but you have to set your calculator in terms of the radian. So you will get the answer is 5.75516. Look at the next one. Compute the integrals. Again, you can see a is my 0, b is equal to pi by 2. My target is to find the limits. Change the limit from a comma b, that is a 0 comma pi by 2 to minus 1 comma 1. So what is the b minus a over 2? It's a pi over 4 plus pi over 4. Therefore, dx will be pi over 4 into du. I can substitute all these values in the given functions. It's a minus 1, 2 plus 1 sine of the x. X will be pi over 4 into u plus pi over 4. And it's a pi over 4 of du. Fine. Now the limits are from minus 1 to plus 1. This function will be my f. Then I can apply the 1-point Gauss Quadrature formula. Answer will be, it is a pi over 2 f of 0. This number is my f. So I can say sine of pi over 4. Sine pi over 4 is a 45. That's a pi over 2 root 2. You can solve them. You can solve all those calculations at least 4 decimal places. If nothing is mentioned in the given statement, you can calculate the result at least 4 decimal places. Fine. Now look at the second part. Your target is to calculate the errors. Fine. Always remember this answer is my approximate. So then you can firstly calculate the exact value. Exact value means you can solve the given integration. What is the integration of the sine x? It's a minus of cos x from 0 to pi by 2. So that number will be cos of pi by 2 is 0. Cos of 0 is 1. So exact value is my 1. Now once we know the exact value is 1, approximate value will be here. So therefore we can find the true error. It will be exact value minus approximate value. What is the exact value? 1. Approximate value will be 1.11072. So the answer is minus 0.1172 is the true error. Second is you can calculate the absolute error, or you can call as the absolute relative error. That is given as a true value minus approximate value. True value will be 1 minus 1.11072 divided by 1 absolute value into 100. So the answer will be 11.072 percentage is the right answer of the problem. Look at the next one. Compute the integral using the Gauss-Legendre 1-point formula. एक चीज आपने अगर नोट करी हो, if you closely remember that all these numerical examples, the same example I had solved with the 2-point Gauss Quadrature rule also. आप देखोगे सेम एग्जाम्पल्स मैंने 2-point फॉर्मूले से भी सॉल्व करी हैं और इस वीडियो में सेम एग्जाम्पल्स मैं 1-point फॉर्मूले से भी सॉल्व कर रहा हूं. नाउ योर a will be minus of 2, b will be plus of 2. Your target is to change the limits from to minus 1 to plus 1. What is a b minus a over 2? It's a 2 plus 2, 4. 4 over and b plus a is my 0. Therefore, dx will be twice of du. I can substitute the values. Your given integration becomes minus 1 to plus 1 e raised to power minus x over 2 minus of u. Dx will be twice of du. Fine. Now the limits are minus 1 to plus 1. The function e raised to power minus of u is my f. I can substitute the value twice. This number is my twice, and this is the formula of the Gauss-Lysander 1-point formula. That is 4 e raised to power minus 0. 4 is the right answer of the problem. If somebody will ask you calculate the error, fine, you can do that. You can firstly find the exact answer. You can find the exact value. Fine, you can integrate them. Fine, and then you can subtract from the 4, you will get the error. Compute the integrations 0 to 1 x into ex and then find the errors part also. So again, our target is to firstly change the limits by using the substitution b minus a over 2. What is the b minus a over 2 is? Half of u plus half. Therefore, dx will be half of du. Fine. You can substitute the value. I will be, limits are from minus 1 to plus 1. X is my u plus 1 over 2. E raised to power u plus 1 over 2 into half of du. So I can take in 2 and 2 is a 1 over 4 is outside. Limit is from minus 1 to plus 1. U plus 1 e raised to power u plus 1 over 2. Now you can see the limits are minus 1 to 1. Therefore, this component is my f. So by using the 1-point Gauss Quadrature rule, my answer is 1 over 4 is outside, 2 into f naught. So that will be 1 over 2. This number is my f. I can substitute the value 0. 0 plus 1 e raised to power 0 plus 1 over 2. So that will be half. Root e is the right answer of the problem. Make sure students f आपको -1 से 1 वाली लिमिट का लेना है. अगर आपने ओरिजिनल फंक्शन का f ले लिया, that will be the wrong. f is always taken of the integral whose limit is -1 to +1. Fine. Okay, now this is the approximate answer. How you can solve these integrations? Remember, you can always use my shortcut tricks for finding. You can use there are the two ways. You can solve either integration by parts. Fine. This is the first derivative, then integrations and so on. Otherwise, एक क्या रूल बताया था आपको? आप इसको दो पार्ट्स में ब्रेक कर लीजिए. Fine. Whenever there is a polynomial, try to find the derivative of the polynomial until it becomes a 0. First derivative is 1, second is 0. And this side you can use as the integration. What is the integration is? E raised to power x is e raised to power x, e raised to power x. Then you can cross multiply them. Fine. With the sign plus, minus and so on. So the answer is, you can multiply them, x e raised to power x minus 1 into e raised to power x from 0 to 1. So can you solve them? If you substitute 1, it is e raised to power 1 minus e raised to power 1. If you substitute 0, so the answer will be 1. So the exact value will be my 1. Therefore, your error, true error will be exact value, fine, minus approximate value. So exact value will be 1. This is the exact value. Approximate value will be minus 0.82436. If you subtract them, you will get as 0.17564. And hence, you can find the absolute relative error, which is defined as 1 minus 0.82436. True value is my 1 multiplied by 100. So your answer is 17.564% is the absolute relative error. Dear student, kindly like and comment on the videos as well. Evaluate the integrations by subdividing the intervals into the two equal parts. That means your domain is 0 to 1. You have to divide the interval such that area of the 1, area of the 2 are same. So can you identify this limit? Definitely it will be the half. So that means your integration 0 to 1 of 1 plus x into dx, that number I can break from 0 to half, fine, and half to 1. Clear? So now there are the two components I call as the I1 and I2. And then you can solve these two portions by using Gauss-Legendre 1-point formula. So I can start with the I1 firstly. Now for the I1, A is equal to 0, B is equal to half. So I can convert the limits by using the substitution. X is equal to B minus A over 2, B plus A over 2, and dx will be 1 over 4 into du. I can substitute the values in the given I1. So I1 is, limits are from -1 to +1, 1 over x. X will be u plus 1 over 4 into 1 over 4 du. So -1 to +1. If you take on the LCM, 4 will be cancelled out. U plus 5 of du. Fine. Now by using the Gauss-Legendre 1-point formula, this number is my f. Fine. So it is a twice of f0. F0 is my 1 over 5. That is a 0.4. So this number will be 0.4 plus I2. Now similarly, this is my I2. I can solve the similar way for the I2. What is the x? A will be my half. B will be my 1. So B minus A divided by 2. B plus A divided by 2. So the dx will be 1 over 4 into d. Substitute the values in the given I2. You will get -1 to +1, 1 over u plus 7. Therefore, by using the 1-point Gauss Quadrature formula, it is twice of f0. This number is my f. Answer is 2 over 7. So I can substitute both the answer here. It is a 2 over 5 plus 2 over 7. So that will be 24 divided by 35 is the right answer of the problem. Look at this another one. Compute the integral by using the 1-point Gauss Quadrature formula. Again you can see the limits are not from the -1 to +1. So I can change the limits by using the substitution b minus a over 2, b plus a over 2. Therefore dx will be half of du. I can substitute both the values x and dx in the given functions. Twice of the x, u plus 3 over 2 divided by 1 plus u plus 3 over 2 raised to power 4 into 1 over 2 of du. So that will be 1, 2, -1. 2 and 2 will be cancelled. U plus 3, half will be outside. That half will be outside. So 1 plus u plus 3 raised to power 4 over 16. Now if you take the LCM, -1 to 1, 16 is LCM, 2 will be cancelled. It's a 8 times u plus 3, 16 plus u plus 3 raised to power 4. Fine. Now you can apply the Gauss 1-point formula. What is the answer of this? It's a twice f of 0. This number is my, this complete is my f. So that will be 8 into 0 plus 3 divided by 16 plus 3 raised to power 4. Now you can solve this by the calculator. You will get answer as 4.49484 is the right answer. And then you can compare with the exact value. How you can find the exact value? How you can solve this integration? I can use the substitution. X square is equal to t. Therefore 2x dx will be my dt. So this number will be dt divided by 1 plus t square. And what's the limit? When x is equal to 1, t will be 1. When x is equal to 4, x is equal to 2, t will be 4. Therefore, by using the substitution, your integration becomes here. So that number will be tan inverse of t from 1 to 4. Fine. So that number will be tan inverse of 4 minus tan inverse of 1. Make sure once you can calculate your answers of the sine, cosine, tan and so on, your answer must be in terms set in terms of the radians. So after the calculator, you can get the answer as 0.5408. So you can get the error. So exact value is 0.5408. Approximate value is 0.49484. You will get the answer is 0.04856 is the right answer. Compute the integration by using the Gauss Quadrature 1-point formula. Again, the limit is not from the -1 to +1. I can use the substitution b minus a over 2, b plus a over 2. You can find the value of the dx. You can substitute the value in the given integral -1 to +1, 1 over u plus 1 divided by 2, half of du. Now you can take the LCM. 2 will be cancelled out. U plus 3 of du. Fine. Now you can, now this is my f. Fine. So by using the 1-point Gauss Quadrature formula, it is a twice of f0. So what is the f0? So 0 plus 3, answer is 2 over 3 is the right answer of the problem. Okay, look at this next one. Compute the integral by using the Gauss Quadrature 1-point formula. Again, the limits are not from -1 to +1. I can use the substitution b minus a over 2, b plus a over 2. Your dx will be du. Fine. So you can substitute the value in the given I. It is from -1 to +1, x u plus 1 square, 3 u plus 1 plus of 2 into dx. dx will be du. Now you can solve this value. You can little bit solve this. I can open this bracket, is a square plus b square plus 2ab minus of 3u minus of 3 plus 2. Now you can see that 1 plus 2, 3 will be cancelled. 1, 2 minus 1 is a u square minus u. Fine. Now u square minus u will be your f. You can substitute the value. It will be 0 minus 0. The approximate answer will be 0. And if you want to calculate the error, you can calculate the exact value by using the integrations. That is my exact answer. Fine. And then you can find the error if you want to calculate the error as well. Fine. So the exact approximate answer will be 0. You can see all these problems I have solved with a 1-point formula. For that 2-point formula, you can watch this example. Same यही example, जितनी भी example मैंने इसमें solve करी हैं, same examples मैंने 2-point formula से भी solve करके आपको इसमें दिखाई है. You can see your answers, compare them. What will be the exact answer? What is the error in each case? I hope you can enjoy this session too. We will see the next lecture on the 3-point Gauss Quadrature formula. Till then, you can like, you can share this video with your friends. Happy learning always. Thanks for the watching. Best wishes.